We're going to do an example where we use the normal distribution to help us approximate something that's a binomial distribution. So here our problem says during autumn semester of 2015, 32% of students enrolled at COTC were under 21 years old. So this says if you took a random sample of 50 students, what's the probability that, and then we have several different situations, 5 different situations that we'll all solve slightly separately. So first let's do some setup work. So this is a binomial distribution. Our fixed number of trials, we've got 50 students, so that's going to be n equals 50. Our probability that any of them are under 21 years old, here is 32%. Our p is going to be 0.32. Either a student is 21 years old or they're not. Any student is independent of the other. Fixed number of trials. And every student would have the same probability if we chose them of being under 21 years old. So if we're going to use a normal distribution, we need a mean and our standard deviation. Now we know for a binomial distribution, the mean we do n times p. So here we're going to do 50 times 0.32. Okay, so you can quickly do that on your calculator. 50 times 0.32, we get 16. And remember, the standard deviation for the normal distribution is the square root of n times p times q, where q is 1 minus p. So this is going to be the square root of 50 times 0.32, and 1 minus 0.32 would be 0.68. Sorry, my pen's messing up there a little bit. 68. So if we do square root of 50 times 0.32 times 0.68. If I round this to 2 decimal places, we're going to have 3.30. So we'll use that as our standard deviation. Now, as explained in the last video, we're using a continuous distribution to approximate something that's discrete, meaning, if we pick 30 students here, we pick 50 students, the number of them that we could have under 21 would be 0 students could be under 21, 1 student, 2 students. We can't have 2.5 students. But if we're using the normal distribution is continuous, so we have to use what's called a continuity, let me get the right word, continuity correction. And so basically we need to think of, here all of these are about being exactly 30 of them under 21, or at least 30, more than 30, at most 30. So all of this is kind of around 30 students. So what we need to do here we're going to use a normal distribution. Sorry, my pen skills on here aren't great. The mean we found is 16, and our standard deviation is 3.30. So we'll use that, and we can do it on our calculator. But everything is going to be about or around 30. Now, our continuity correction, we're going to use values. We're going to subtract 0.5, which would give us 29.5, and we're going to add 0.5, 30.5, and we're going to use these 0.5 values, halfway between our next value and down and up, 29 or 31. When we do this, we're kind of splitting the difference between 30 and either other discrete values on either side. So when we want to do exactly 30 of them, well, let me remind you, we can do all of these on our calculator if we do normal CDF, and then we're going to put our lower value, our upper value with commas in between them, our mean, and then our standard deviation. So for all of these, our mean is going to be 16, and our standard deviation is going to be 3.30. The important thing for A through E is what our upper and lower values are. So we'll write those down, and then we'll use the calculator to actually find our probability. So when we want exactly 30 students, we're going to go between our two, we can't just say 30 because remember exactly on any normal is 0 probability. So we're going to go between 29.5 and 30.5. So we'll do the normal CDF. Our lower here will be 29.5 and our upper will be 30.5. So do this in the calculator. We'll do second distribution, second vars, and we want normal CDF, so we're going to choose 2. We're going to put in our lower value of 29.5, comma, our upper value of 30.5, comma, our mean 16, comma, our standard deviation of 3.30. And if you have a newer version, an 84 plus that has some of the newer software, it'll lead you through this. It'll tell you lower, upper, mean, and standard deviation. But if you just have an 83 or it just comes up like this is how you can do it. Okay, so we get that exactly 30 students here. We get this number and e to the negative 5. Well, that e to the negative 5 means we need to move the decimal place 5 places to the left. So if we do that, we're going to have 0.0000, and I'll round to 4 digits that aren't 0, 1, 5, 9, 3. So a really small probability that exactly 30 of them are under 21 years old. Okay, now let's look at B. So B says at least 30. So that means we would include 30 and we would want all the way up to 50. Now, when we're using the normal distribution, we're actually not going to just stop at 50. We're going to think of it going on forever. And so we would, our lower, well here, when we think at least 30, that means we want to include 30. So we're going to go this way. We're going to shade it into the right. Since we want to include 30, we're going to go down to where our continuity correction starts. So our lower value here is going to be 29.5, and our upper is technically going to be infinity, but as far as our calculator goes, using something like 1,000 is good enough. So we're going to use normal CDF. We're going to do 29.5, comma, 1,000, and then our mean and our standard deviation stay the same. Okay, again, we get a really small value here. We're going to have to move 5 decimal places to the left, but we see it's 0.0002150 if we round to 4 decimal places. Okay. But for at least 30, you would, or at least whatever, you would go down to the continuity correction, and then you would want everything above it. Now, what if it says more than 30? More than 30 means we want 31 students being over 21, 32, you know, and like it says more than 30. We're not going to include 30. So let's see if I can carefully erase what I shaded here. When we want strictly more than, we don't want to include 30, what we're going to do is we're going to use our continuity correction, the one that's above 30, the 30.5, and use everything above that. So we're not including 30. So we're still going to go up to infinity, or on our calculator 1,000, but our lower limit now is going to be 30.5. Okay, so if we do that on our calculator, so we're going to do 30. And while I put this in there, the reason we're getting such small values is that this is you know, if our mean is, we'd expect about 16 of these students, we're way outside 2 standard deviations. So we would expect this to be pretty unusual. Okay, so here we need to move 6 decimal places, so it's going to be 0.1, 2, 3, 4, 5, and then 5, 5, 7. Okay, so here we have exactly 30, at least 30, and more than 30. So now we're going to, I'm going to erase some of this. Let's see if I can. That didn't help. I'll scroll down some. Oops, sorry. Now, if we want to do at most 30, that means we want to have everything lower than 30 but include 30. So I'm going to use this just to erase what we had shaded in. So we want everything lower than 30, but since we are going to include, so that would be everything down here, but since we do want to include 30, at most 30, meaning we can have 30, we're going to go up to that, so kind of the maximum area we could have with our continuity correction. So our lower here, you know, ideally it would be negative infinity, but on our calculator we'll do negative 1,000, and our upper will be 30.5. So we're going to do our normal CDF. We're going to do negative 1,000 to 30.5. And this should be a pretty high probability. Okay, so here our probability value would be 0.99. How many nines do we have there? 1, 2, 3, 4, 5, and then a 4. 1, 2, 3, 4, 5, 4. Okay, so our last one, which you can probably see kind of the pattern we're doing. So here, sorry as I try to fit this on here, but so for E, we want fewer of them, fewer than 30, meaning we don't want to include 30. So you can, like I said, probably see the pattern. We're now going to stop at 29.5. So close to 30, but not quite. So again, our lower will be negative 1,000. And our upper will be 29.5. Negative 1,000 to the lower bound of our continuity correction, so 29.5, and then our mean and our standard deviation. Okay, and again, this is really likely to happen. 0.99998 if we round there. Okay, so again, this is, you want to make your continuity correction, which you take whatever number you're kind of looking at and you're going to subtract 0.5 and add 0.5. And then based on whether it's exactly, at least, more than, at most, or fewer than, you use those bounds as we've shown here.